I mentioned in class the sandwich theorem, or sometimes known as the squeeze theorem. Uh, this is really a last resort for finding a limit. And really, where this comes in is say you found a limit graphically, but you're having trouble with confirming it algebraically. The sandwich theorem is a way to provide that confirmation algebraically. However, you really need to have a picture or a graph to look at to help you with this. It's just that among mathematicians, just saying, oh, I can see it on the graph is not justification enough. Mathematicians like to say, this is it algebraically. And so the idea of this is say we're looking for the limit of function h, which is here in blue, as x approaches a. The first thing I need to do is I need to pick a function that's always greater than or equal to h, so I'm calling that one f. And second, I need to pick a function always less than or equal to h, which is g, and they are allowed to equal, it's just f is always above, g is always below. They're the bread in the sandwich. And then I want to pick f and g such that their limits as x approaches a are the same. And because h is always between them, that forces the limit of h as x approaches a to also be the same. And so I did want to illustrate this uh, using the limit as x approaches 0 of sine of x over x. Now we can look at a graph of this, and we can see from the graph that this is approaching 1. Uh, and on the AP test, that pretty much is fine. And actually, I would tell you, you want to go ahead and just remember this limit as x approaches 0 of sine of x over x equals 1. That's going to be one that we see over and over again. Uh, but the case where the squeeze theorem comes in would be that I need to confirm this algebraically. And so the way we're going to do that is, again, the graph is a huge help. The first thing being, I want to pick something that's always going to be greater than or equal to this function. I like to start with the most basic things I can find, linear equations being the most basic function. If linear is not going to work, I'll then try quadratic and work up to more complex that way, but I try to keep it simple. Now, in this case, with the sine of x over x, I can see that if f of x just equals 1, my sine of x over x is always going to be less than or equal to it. Now, for a function that's always going to be smaller, there's not going to be a linear function that does that. However, let's say I pick a quadratic, a parabola. Well, if I have a parabola like this, and this would be 1 minus x squared, that will always be less than or equal to the sine of x over x. And so I've got the top slice of bread is 1, the bottom slice of bread is 1 minus x squared, and the sine of x over x is always between those. Now, the reason I chose those is because of their limits. So, kind of continuing my work algebraically, I know that 1 is less than or equal to the sine of x over x, which is going to be less than or equal to 1 minus x squared. Well, this means that when I take the limits as x approaches 0 of each of these, and the limit is an operation, so if I do it to one of these, I have to do it to all of them. Now, I don't know what that is in the middle, because that's what I'm looking for. However, for the limit as x approaches 0 of 1, well, that's one of our properties, which you should have just watched the video on. So that's 1. And the limit as x approaches 0 of 1 minus x squared, I can do substitution on. I stick 0 in for x, and I also get 1. So my limit as x approaches 0 of sine of x over x is always going to be between 1 and 1, which means we have now algebraically shown that the limit as x approaches 0 of sine of x over x must equal 1. And that's the key here, is this is proven it algebraically. However, you really need a graph to help you pick your F and G to always be above and below. So you're not going to see this very often, and this is why um, it is a last resort. It's been 3 or 4 years since I've seen any problem that even lends itself to it on the AP test, and even then, it was a problem that one of the other methods will work with.